Okay, so Josh McGrath hit the first part of our three-part series that we've been going around Kentucky giving, with the middle part of the series, and then Jordan Shockley, an economist at UK, wraps up the third. So today I'm a soils guy that works in poultry litter, so I can't really give a poultry litter talk without touching on the principles and importance of soil sampling. Then we're going to get into manure use, and I'm going to talk about determining manure rates or manure availabilities, then manure sampling, manure testing, some field research. I have several slides here from Kentucky, and then what's the value of that manure. So why do we soil sample? We want to know what the nutrient status of that soil is so we can produce the end results we want. We want to maximize yield. Soil samples should indicate the current nutrient status of that field. So it guides us in adding the appropriate rates. We want to make sure that we apply enough that we don't limit yield, but we don't want to apply so much that we're wasting money. So there's two ways to lose money by not soil sampling or by applying nutrients. One, we apply too much, gets into your pocketbook, you don't see a yield response. But the bigger way that you lose money by applying fertilizer is not applying enough. So if you're just guessing, there's a chance you're going to hit right on, but there's a good chance that you're going to either over apply or under apply. And then typically under applying, costing yourself yield is what's going to get into your pocket a little bit deeper. Cost of soil sampling is really pretty cheap. For Kentucky, our regulatory services at UK, they charge $6 a sample. A lot of the counties will charge $6 a sample, ship it in for free. Sometimes they'll add $1 to that sample, so now it's a $7 sample to cover shipping. Some counties have enough of a county extension tax that they subsidize soil sampling. So you might be able to go all year and never have to pay for a soil sample because your extension office covers it. So it varies according to where we are, but in no place that I'm aware of out of our 120 counties, it's going to cost you more than $7. That's a pretty good investment. But to do all what we said up here, it has to be a good sample. So what's a good sample? A good sample is a representative sample of that field. In Kentucky, we base it on drainage, cropping history, erosion, and then past management. So for example, if we have I know I'm going to talk about manure here in a minute, but I'm not talking about a manure application at this point. I'm talking about what if 30 years ago this is where my dairy was and this was a stalling area before we milked them. That 2 or 3 acres is going to have increased levels of P and K most likely, and not going to be the same as the rest of that big field now. Tobacco is a big thing, still a big thing in Kentucky, not as big as it was 15 or 20 years ago, but it's a high dollar crop, probably applicable to vegetables in this area. You have a high dollar crop, you're going to make sure I'm not limiting my yield by under applying nutrients. Fence rows. There's a lot of fence rows that have been taken out in the past 15 years in western Kentucky. Equipment's getting bigger, they're consolidating, so instead of a 20-acre field here and a 30-acre field here, let's get the track hoe and the bulldozer in here, knock this fence row out, and now I have a 50-acre field. Well, you want to make sure that that 50-acre field or that 30 and 20-acre field are pretty similar in nutrient status before you start sampling it together and making your fertilizer recommendation on it. We'll recommend at least 10 cores. That's on the low end. The more, the better. The more soil cores you take, the closer to reality you're going to be. And I have a picture I'm going to show here in a minute to try to make that point. How often do we sample? We usually recommend every 2 years. If you have a high dollar crop or a high removal crop, we're going to say every year. We just don't want you to get caught in a bad fertility status. And then fall or spring. I use this analogy just about any time I talk to producers or people about soil sampling. Fall and spring are going to give you different results. But if you look at a fall of 2013 versus a fall of 2014 versus a fall of 2015, you're comparing apples to apples. But you don't want to look at fall of 2013 to a spring of 2014. It's different. It's kind of just like my weight. The doctor, every time I goes there, he has a big thing about my weight. He said, Edwin, you need to lose some weight. So I went out and bought some bathroom scales. Every night before I went to bed till I broke the scales, I'd look at it and I'd weigh somewhere around 210, 215 pounds, depending on what time of the year it was. I'd get up in the morning, I'd weigh 3 to 5 pounds less. So did I really lose 3 to 5 pounds just by going to sleep? I didn't. I'm comparing apples to eggs. So what I need to do is make sure if I'm going down from bedtime to bedtime to bedtime, I'm losing weight. Same thing here. Watch what your trends are doing over time. I'm adding this recommendation, I'm trending up, I can back off a little bit. I'm adding this on this soil type. Guess what? I'm trending down a little bit. Maybe I need to bump it up just a little bit. So what our soil extractant does, we use a Malic 3 in Kentucky. A lot of people use a Malic 3 as well. So it's getting the nutrient here in the soil solution. That is immediately available to the plant. The plant can take that up. When that's taken up by the plant, then we have the readily available form that's going to shift over into this solution phase and be available for the plant. And then we have some slowly available stuff trapped in the interlayers, stuff in the mineral form that has to dissolve to be into the plant available forms. So our Malic 3 extractant or our soil test extractant is getting a good idea of what nutrient is going to be available to that plant in that growing season. The analogy I like to use, I hope it makes sense, is this chicken water. I talk a lot about chickens. So if this holds 5 gallons of water and I fill it up with 5 gallons of water, I know my chickens have 5 gallons of water that they can drink the next day. So what if I now take this and have a 4-gallon block of ice, and I put it in there and I start beating on it with a hammer, and then I pour a gallon of water on top of it? Well, those little chips of ice are going to break down, and my chickens are probably going to be able to drink that the next day. The stuff that's a little bit bigger, the big small pieces, they're probably going to melt, and it's going to be available for my chickens. But that big block of ice that might be representing a gallon of water, that's probably not going to break down. So that's the same thing our soil test extractant is doing. It's trying to get us an idea of how much we're going to get in a growing season. This is from the University of Kentucky, a soil test report. I'm sure yours look different from Delaware, Maryland, but what it's going to give you is, or what ours gives us, and I assume yours, some sort of status of where your phosphorus, your potassium, pH and buffer pH are, and then zinc. And then based on what crop you're growing, what management practices you're employing, it's going to give you a recommendation. So what I tell my producers, look at pK to get your recommendations for phosphorus and potash, soil pH and buffer pH. That's going to give you your lime recommendation, and then zinc. Do you need zinc for corn? Ignore most of the other stuff. It's just noise, so to speak. You look at those 4 or 5 things, you're going to be in pretty good shape. So we say pH is the master variable. We recommend a pH of 6.4 as a target pH for all of our row crops, and then we go up to 6.8 for alfalfa. So we're going to say 6.5 is the magic number. That's what they teach you in school. That's a good number to go by. Why is that? Well, these lines represent the fatter the line, the more available it is for plant uptake. If you go down here at 6.4, 6.5, you see we're catching the pretty fat parts of the line. That's a good thing. Potassium. And then we hit calcium, and then we hit phosphates. Well, if we get too much above 7, calcium and phosphorus are going to interact. So I have lower availability of phosphorus at pH of 7 than I do 6.5. If I go to the other end, if I get down below 5.5 or 5, now my aluminum and my iron are starting to tie up the phosphorus, which is less available for plant uptake. And another thing, when you start getting below 5, aluminum and manganese can become toxic to roots. Manganese is an essential micronutrient, but too much of a good thing isn't necessarily a good thing. So it goes from sufficient to can be toxic and start dinging up the roots. So on to animal manures. I know that's what the title of my talk is, so I better talk a little bit about poultry litter. So it's been around for a long time. The Greek poet Homer mentioned it in the Odyssey, 800 years BC, almost 3,000 years ago. About 2,000 years ago it was mentioned in the Bible. So we have documentation that the use of manure has been around for a long time. Around the turn of the century, the turn of the 19th or 20th century, in the early 1900s, 19-teens, Haber and Bosch independently figured out how to take this N2 gas, the 78% or whatever we're breathing now, and make it into a fertilizer, a nitrogen compound. Same thing legumes do. Well, during World War II, we had access, we being the U.S., to saltpeter reserves that were used to make munitions, bombs. A lot of the Axis countries did not have that, but they had this inorganic Haber-Bosch process, so they ramped up production to make nitric acid so they could make bombs. Well, guess what? The war ended, and we had all these plants that were online that could make cheap fertilizer nitrogen. Well, now we had cheap fertilizer nitrogen. We don't need to make bombs. Let's make fertilizer. So the use of manure kind of from 3,000 years ago started going downhill drastically, because now I could buy 100 pounds of urea and get 46 pounds of nitrogen instead of buying a ton or hauling a ton of poultry litter to get 46 pounds of nitrogen. Then it went back to found favor again. Hey, we're producing a lot of this poultry litter. Maybe I don't need to be dumping 30 pounds per acre or 30 tons per acre on my ground. There's some value to this. So it's now kind of found favor again, especially with the NRCS soil health deal. That's one of the main pillars of soil health, animal manures. And there's a lot of good things involved with animal manures. So how do we best utilize that value? There's three forms that I really care about in poultry litter or any animal manure. The two inorganic forms are ammonium, NH4+, and nitrate, NO3-. This one typically sticks around till it converts, till it nitrifies to nitrate, and then nitrate can either be taken up by the plant, leached, or denitrified. And then we have the organic soil in. That's your amino acids, your proteins, the microbial biomass. This is what the people, when they came over in the Mayflower, when they were burying fish under their corn plant to make it grow, this is the form they were putting it down. Over time, it broke down into ammonium and nitrate. So we're talking about a slow-release fertilizer. Here's a picture of the nitrogen cycle for those of y'all that heard Josh talk earlier. It's pretty much the same cycle, just looking at it a different way. So we have our animal manures and our biosolids in this organic form. They're going to convert to ammonium or nitrate or an ammonia, NH3 without a plus, which is the gas that can volatilize. When you walk in a chicken house, the stuff that burns your eyes, that's the ammonia. We can lose it by runoff and erosion, volatilization, denitrification, which is our major concern in Kentucky. Our soils have a bottom. They're not sand 5 foot deep. So water will start stacking up. When the microbes in the soil run out of oxygen in that water, they start stealing an oxygen from this nitrate. Once it's out of the NO3 form, it's not plant available. And then around here, I believe leaching is the more dominant loss mechanism. So this is some work that was done in the early 90s by some of my predecessors. I'm trying to generate enough data to update this, but the concept still holds true. So if we look at nitrogen that is being applied in the spring from a manure, specifically poultry litter here, and it is incorporated either with tillage or rainfall, within 2 days we say, well, it's about 60% available. That's probably not a bad number, but it's not a real good number either. But the longer it is on that surface without incorporation, either with still or rain, the less nitrogen we're going to have available to get into that plant. And what that's looking at is ammonia volatilization. That N3 gas is going up into the air, not getting into the soil, not being available for crop use. If we get it in the soil, either by rain or still, it's going to grab a hydrogen out of the soil and go to NH4 plus, and then it's going to stick around. So getting it in association with the soil is a good thing. And then this next one, we have corn or annual grasses, and we applied our poultry litter in the fall. Well, it goes from about 45 as a spring application down to 15% availability with no cover crop, or they say 50% availability if I have a cover crop or if it's applied pre-plant to a small grain. These numbers, I believe, for the 50% are a little bit high, and I've got some data to show you here in a minute. But what this is showing, this 15%, is mostly that over winter denitrification and leaching losses. We put it out there, the mechanism, the mineralization process is still going on, plants aren't growing, there's nothing to take it up. What does it do? It either goes through the soil, pile drain, or denitrifies. So manure sampling is just as critical and challenging, I argue probably more challenging than soil sampling. But most of the time we'd like to base our application on this sample. So it requires a representative sample. I don't know if any of the people in this picture are in this room. Apparently 4 of them were last time, but I use this picture a lot in Kentucky because really no one knows these people, and I can tell you how old they are, or how old they are for this example. So that's Josh. Whether he is or not, for this example, he's 40 years old. This guy right here, for this example, I say he's 20 years old. This guy's 30 years old, 40, 50, and 60. Add all that up, it's 200. Divide it by 5, we come out with 40. So the average age of this group is 40 years old. So if the one sample I select to get the average age of this group happens to be Josh, I nailed it on the head. But if I pick this 20-year-old or this 60-year-old, I'm off by 20 years. Any 2 samples that I pick are going to be closer to that average, that true average, if my one sample is either 20 or 60. Is that making sense? If I take 3, I'm going to get closer. So that's the same thing as this manure sampling. If I just take one sample, there's a chance it might represent that 150-ton pile, but there's a pretty good chance that it won't. So take several samples and mix them together. We say 10 or 15, depending on how big the pile is. Take it from different areas in the pile, knock the crust off and get into the pile. Take you a scoop, throw it in a bucket, plastic bucket. Please don't use the galvanized because you can contaminate your sample with zinc. But take it from different spots in that pile and then mix it up thoroughly, and then take your Ziploc bag or whatever you submit your manure samples in, take a subsample out of that bucket and submit it to the lab for analysis. I know this is a busy graph, don't get hung up on it, but one of the things I was trying to do, a lot of our producers do not manure sample. They pull up to their manure broker or whatever and say, I'll take 100 tons. They don't generally ask what's the nutrient analysis. If they do ask, chances are the answer is, well, I don't know, do you want it? So that's how it's working in Kentucky right now. So what I tried to do, I have access to all the soil and manure samples that go through the University of Kentucky Regulatory Services. So I got these samples and I was trying to see if I could group them by integrator to have a better book value to provide to someone. Okay, I'm getting Tyson broiler litter. What's a good book value? Well, let's look. Well, guess what? It didn't work out because a lot of people didn't put enough information on there, and there's so much variation. So I looked at Tyson, Cal-Maine, this is Layer, Equity Group or Pilgrim's Pride, some breeder houses, Purdue, there were 5 samples that were labeled, and then when there were 369 samples that didn't have an integrator identified. They just didn't know. So there's about 700 samples here, so I'm just going to zero in on this all other poultry litter. So I have my water content, carbon, nitrogen, phosphorus, and potash. This 369 samples, the average for nitrogen was 46 pounds per ton. 56 pounds of phosphorus, 46 pounds of potash. That's not too bad. In our AGR1 nutrient recommendations, we say broiler litter is about a 55, 55, 45. Well, that's not too far off if you happen to get an average of these 369 samples. But if you look at the minimum, and this isn't a minimum of one sample, the lowest nitrogen content out of these 369 was 12 pounds. The lowest phosphorus was 4 and potash 2. That's 3 different samples, but nonetheless, it's showing you there's a low end to that range or that average. If you look at the maximum end, 186, 116, 109. So now I'm buying poultry litter at $40 a ton, and I think I'm getting a 46, 56, 46, but I end up getting a 12.42. Not too happy. That $25 sample was probably going to pay off if you're buying a bunch of tons of this stuff. Now on the flip side, if I get a 186, 116, 109, hey, I hit the jackpot. My luck is this is what I'm buying right here. So I just always recommend if you don't know what you're getting, if you're getting it from a new source or a broker that's just cleaning out houses, take a few samples so you know what you have. If you're going back to the same producer every year, you know what he's doing. Okay, I run 6 flocks through here a year. They stay on here about this many days. Yeah, you probably can get by without sampling as often. Just take a few to make sure, but $25 sample is going to really save you in the long run. This is what a sample looks like from the University of Kentucky. I don't want to get between you guys and the beer wagon, so please, and we'll try to stay on time. The manure test report here is what we do. This is a $25 test. We test the moisture first. So this is 46% moisture. A lot of people don't think of it this way, but in a ton of poultry litter, I just bought 920 pounds of water. So if you think about it that way, the drier the better. You get more bang for your buck generally. But these values over here, the MP and K, are reflective of this 46% moisture. So even with 920 pounds of water, I'm still getting 45 pounds of nitrogen, 32 pounds of phosphorus, and 39 pounds of potash. So this is reported in pounds per ton. What they will also do is report it as a percentage, like a fertilizer analysis, triple 10 or triple 15. So pounds per ton, pounds per 2,000 pounds, pounds or percent is pounds per 100 pounds. So divide this number by 20 and we get 2.2. Wait, that's not 2.2, that's 1.1. So what are we doing here? Well, we also put in an equivalent. We say it's about 50% available. Our ranges that are in the UK publications vary from 20 to 80%. I think part of the reason that 50% in there will never be off more than 30%. Just to be honest, we're splitting it. But that's a number that's given in a lot of the literature. So 45 divided by 20 is 2.2. divide that by 2 or multiply it by 0.5. Now we have a 1.1. We say our phosphorus is 80% available. 20 divided into that times 0.8, 1.3. We say all the potash in the litter is immediately available to the plant. So divide that by 2, we get 20, we get 2. That's just how we report it. Don't necessarily agree 100% with that, but that's what we do currently. Some of the private labs, they just give a percent, and then that percent times 20 equals pounds per ton. So same type of deal. It is adjusted for moisture. So that, 32 pounds per ton does consider, what is that, 900 pounds of water. So this was a series of experiments that I have going on. This integrated approach is funded by the Kentucky Soybean Promotion Board and the Kentucky Corn Promotion Council. They had some questions and I was wanting to look into that. It's an integrated approach because I was the soils guy working with manure. We had a pathologist involved, see if there was something going on in the disease realm. And then we had a weed scientist that was looking into, hey, are we bringing in weed seed? Is it changing the dynamics of the weeds in this system? So I evaluated nitrogen use efficiencies in corn. Hey, is there some reason we're seeing a response of soybeans to this additional poultry litter? And here was the big one for a lot of the producers, the potential for weed seed introduction. If I have time, I'm going to touch on the buildup of phosphorus. And then I had another set of experiments where I was looking at organic amendments for corn and wheat production, essentially trying to zero in on these nitrogen equivalencies. And in this study, I was looking at poultry litter, which is really all I'm going to focus on in this talk. But I do have some data for biosolids and then composted swine manure. So you can see from this slide here, some of the wheat is nice and dark, and then you have some beside it that's pale and yellow and real thin. It all comes down to nitrogen. This probably received a higher rate of inorganic nitrogen. This probably received very little or not a biosolid, but a composted swine manure or real low rate of poultry litter. So what we did, we're on a Zanesville silt loam. That's an alpha soil that has a fragipan at about 30 inches. That fragipan is a restrictive layer. Water cannot get through it. Roots cannot get through it either. So you have essentially 30 inches of rooting depth. I applied the poultry litter and the other products based on my total nitrogen. Took a sample, sent it to the lab. Whatever that test result was what I added based on that total nitrogen, assuming 100% of it's available. I know it wasn't available, but we were trying to back into how much of that total nitrogen we applied actually got back into the plant. So for wheat, I applied 100, 150, and 200 pounds of total nitrogen. For corn, 100, 200, and 300. And then my response curves, my nitrogen response curves, for wheat, I went up to 120 pounds. Talked to any good soil fertility guy. I didn't get this up high enough. It didn't break. I knew that when I was setting it up. I was trying to get a refinement on the lower end. I didn't have enough room to put a couple more rates like I would have. And then for corn, we went up to 200 pounds. So what those two top end results or recommendations are our highest recommendations for wheat and corn currently from the university. So I'm going to try to, Josh said I confused him a little bit, so I'm going to try to do better this time. So this blue line, what that is my response curve from the inorganic nitrogen. There's my, this is for corn, so that's 50, 100, 150, 200 pounds of total nitrogen. And then I have these lines here. So this one's for my poultry litter. So what I did, this yield, I had 200 pounds of nitrogen. I run it over here to my commercial fertilizer. So at that point, how much nitrogen did I apply to get the same yield? So just eyeballing it, about 30 or 40 pounds of nitrogen from this poultry litter to get the same yield. 30 or 40 pounds from the commercial fertilizer to get the same yield as I did in that poultry litter. Looking at, that's the exact same data right here. So looking at my nitrogen fertilizer equivalents, I ended up getting about 35 pounds of nitrogen from that poultry litter, or 35% of the nitrogen, total nitrogen applied compared to the commercial fertilizer. That's a little bit less than the 50% that, I said we typically go with. But then in 2014, the results were a little bit different. It was, you take the average of these three numbers across the three rates, and I'm at about 50%. I've got numbers, I said UK has publications from 20 to 80%. I have results that go from less than 10 to over 80. So it's scattered, but I do feel like this is probably more representative than that 50%. Looking at the same thing in wheat, I didn't highlight this, but our fall applied wheat, or fall applied poultry litter to wheat, we're looking at 7.5 to 9% of that total nitrogen that we applied is getting back into that plant. Remember, we show cover crops or winter wheat or winter small grain being about 50%. It just didn't work out here this year. But then we go to another year and we have some funky data. This is kind of what I expect to see when I'm working in the field with animal manures. Data isn't nice and pretty as it was right here. That was not bad data. This is. But looking at that table again, now that first one, 67% of that nitrogen from that wheat, or from that poultry litter, got into the wheat at my low rate. But as my rates increase, my efficiency went down. So now I'm at about 15 or 25%. It was kind of scattered all over the board, but the data that I have shows that we're going to be probably less than 25% efficient. So one of the things I'd like to do for my producers, a lot of them just write off the nitrogen contribution from their poultry litter. Because, hey, you said I get 50% and I'm not getting nearly 50%. Well, what if I tell you you're getting 20%? Will you take that and then not add 50% more nitrogen with your second application? So that's one of the ways we're trying to go about it. So we'll try to get through this pretty quick. It's kind of confusing. So we have two fields here, field 1 and field 2. Then we have two planting dates, early, or which is on time, October for wheat, or late, and we're looking at early November. Then I have 4 nitrogen rates, 0, 30, 60, 90. And then I collected tissue nitrogen, biomass, multiply the tissue nitrogen content by biomass, and we get nitrogen uptake. So I said I don't think we're 50% efficient with our poultry litter. Now this isn't poultry litter, this is urea, surface applied urea. So with 0 pounds of fall in at the early rate, I took up about 26 pounds of nitrogen. So if we're 50% efficient, that means I can cut this number in half, 90, in half is 45. 45 plus 26 is 71. Lo and behold, I'm pretty close to that, 69. But now let's look at this later planting. This is still not considered too late to plant wheat, but with my 0 rate at the late planting, 16 pounds, cut that 90 in half again, 16 plus 45, 61. Now I'm at 28. So I'm about 20 to 25% efficient. And all this nitrogen here is immediately available. It's fertilizer nitrogen. Put it down, plant can take it up in the next couple days. Poultry litter, on the other hand, there's going to be a pool of ammonium, small pool of nitrate that can be taken up, but the rest of it has to mineralize over time. So we're taking that nitrogen, putting it out when we put the poultry litter down. If the plant can take it up, the plant can take it up and use it. Plant might stop growing when that poultry litter is still mineralizing. Now we have available nitrogen for the plant to take up, but the plant can't take it up because it's not growing. I'm going to skip over this, but I want to talk a little bit about poultry litter yield in soybeans. What's going on here? These are large plot studies, 4 locations. I consistently got a yield bump with poultry litter as compared to equivalent amounts of P and K added as commercial fertilizer. 3 bushels, 3 bushels, 3 bushels, 3 bushels, 4 bushels, 5 bushels. So my first thought was it must be mineralization of nitrogen from my poultry litter. That organic fraction's mineralizing, and at the late part of the year, it's being utilized by the soybean. So, free nitrate in the soil has been shown to reduce the inoculation or infection of the Brady rhizobia on soybean root. We just reduce that. That's the nodule that makes the nitrogen. We also have something going on here around R5. The nodules start shutting down, sloughing off. They're now not fixing as much nitrogen as they were, 20 or 30 days prior. So what's going on at R5? We have maximum nitrogen need to fill that pod. So it's robbing from the plant. So my theory was that the 70 pounds of plant available nitrogen is mineralizing over time, 10 minutes, okay, and hitting the plant at R5 or somewhere around there and filling out the pod. So what we did, I proposed to the soybean board to test this in 2015 and 2016. I have 3 sites listed here, but I actually have 4 sites worth of data. I got one harvested a couple weeks ago that I was able to get in. So have McLean, Henderson. This is where I work, the Research and Education Center in Princeton, and that's the same place I work a year later. So we added either no nitrogen or we came in with 100 pounds of total nitrogen at R1, R3, or R5. I just knew for sure that I was going to see a yield bump. So my no nitrogen in McLean County, 66 bushels per acre. If I added it at R1, R3, or R5, didn't even reach 66. In Henderson County, I started with no nitrogen with 55 bushels, and I saw that first number. I'm like, woohoo, I got something. 5 bushel yield increase, which would be about what I was seeing with my poultry litter. But then the R3, R5, nothing. Look at REC, these were double crop beans, nothing, 47, 48, 47, 47. And then the REC again, we actually went the other direction, down 5 to 7 bushels with the addition of this late season nitrogen. So my theory, hypothesis about the nitrogen mineralizing over time didn't seem to pan out. I've got 2 more site years of data that I don't have worked up yet, but I have a sneaking suspicion it's going to show about the same thing, but we're going to look at it and see what it shows. This is well known. I'm going to just skip over that and then get to this right here. So one of the big concerns people have with using poultry litter in my neck of the woods is our bedding source. We don't use wood shavings. We use rice hulls. Where do rice hulls come from? They don't come from Kentucky. Arkansas. What is Arkansas known for besides Razorbacks? Palmer, amaranth that is resistant to Roundup. So a lot of our farmers are afraid, or some of our farmers, hey, even though I'm buying poultry litter from Kentucky, those rice hulls are bringing something in. So we tested that. We looked at a sterilized soil. We autoclaved it so we knew that soil we're using had no weed seed in it. And then we mixed it with, we had about 15 to 20 different manure samples that came straight out of the house, and mixed 10% poultry litter to 90% soil. That's a pretty hot rate. So we put our checks in here. Our dicot was a soybean and our monocot was corn, and planted 10 of those in each of the trays. And we did 2 trays per sample. We've done this several years. I'll get to that in a second. And the other thing is plant available water. If you're adding organic carbon is the building block for soil organic matter. The higher your soil organic matter is, the better off you are. The more water it'll hold, the less compaction you can see. Well, after 1 year, there was no difference. We still are testing that. Just to summarize this little bullet point right here, making a bunch of assumptions and some spitball math, it's going to take somewhere between 60 and 100 tons of poultry litter to change your organic matter by 1%. So on to this, here's our greenhouse work where we grew the soybean and corn with a 10 to 1 or 1 to 9 dilution. Nothing there. There's a close-up after we harvested it. Pretty clean trays. I can show you result after result after result. So we have not been able to find any weed seeds in this poultry litter coming straight out of the house. The caveat is I had some poultry litter that was stored on the back side of the farm. I was going to use it for experiment, and it fell through. And anyway, it was there for over a year. And I'm glad my people didn't come around and check it from Lexington, because they'd have not been happy. But anyway, we pulled a sample from that, from the crust, and put it in here. And guess what? We found weed seed. The weed scientist that was on this project, he said, yeah, those things, they can move hundreds of yards. It was a wind-borne seed. So if you have a pile at the edge of your field, there is a chance that you are getting weed seed in that, but it's because it probably blew in and you're still spreading that seed within that field. It's not like we're bringing seed from Arkansas. So that's the caveat to that. So if it's not yield, what we're looking at over time, organic matter, increase organic matter, we're going to increase our resistance to compaction, residual nitrogen. Organic matter is a storehouse for a lot of nutrients, nitrogen included. Improvements in infiltration and structure, plant available water. Get about 15 pounds of sulfur. I'm just about done, Sean, thank you. 15 pounds of sulfur from a ton of poultry litter, some other goodies, and a number we've seen a lot. A ton of poultry litter has an R&V of about, or poultry litter has an R&V of about 10. So that means 1 ton of poultry litter is about the same as adding 200 pounds of lime. And then there's some other benefits. So what does this mean? In my mind, for my producers in Kentucky, there's still some questions that I'd like to answer. Our nitrogen availabilities do vary, even though I didn't show you the between. They vary between sources. Poultry litter is going to be different than composted swine manure, but it even varies within products depending on the environment. I feel pretty good saying don't expect 50% availability. I think we would be better off in Kentucky if we back it off, and then these farmers are actually, hey, I am getting something. I know I'm not getting 50, but I'm going to back off my nitrogen. Are they still a good deal? I'd say put a pencil to it and see what you need. So just wrapping it up, what do you need? You need to know what you need, which is soil testing, what you have, testing your manure, pencil it out. Is this a good deal? Well, it depends on what you need and what you have. I feel pretty good saying weed seed do not appear to be a problem. and then we get the other benefits besides MP and K. And just be considerate of your surroundings. We don't have poop police driving around looking for tickets. It's almost 100% complaint driven. You make your neighbor mad, you might have someone from Frankfurt show up. So that's what I've got. If you have any questions, I'll answer them. And